So, hello everyone. My name is Attila Szakács, and I will tell you about metrics, about logs in your observability pipeline, or as the title says, counting what you care about in your security data pipeline. So, quick introduction. My name is Attila Szakács. I'm a founding engineer and tech lead at AxoSyslog, which is a startup where we develop a logging pipeline on steroids, that's how I would introduce it. I'm doing software engineering here. I'm the tech lead of the data plane team. Actually, I had the privilege to develop syslog-ng for more than 7 years now. And I'm also a logging operator maintainer, which is a CNCF sandbox project. So I'm coming from mainly a logging background and from the developer side, not strictly as the user of log pipelines. So my introduction to metrics was probably very different from the rest of you or most of you, more similar to the approach in the next in the previous presentation. So most of the time I looked at metrics to debug the logging pipeline I was developing and maintaining. But I hope because of this, I can give you a slightly different perspective to logs and metrics, maybe one you have not really heard about, or maybe nothing new will come from this, and every one of you knows these, but at least you can see a different path of learning about metrics. Also, I'm a first-time conference speaker. I'm very honored to be here, so I must thank Promcom for having me and starting on this journey. Okay, so what will we hear about today? First, we will talk about what syslog-ng is, if you have not heard about it before, what metrics looked like in syslog-ng previously, and how we transition to Prometheus-style metrics, which I think is interesting to see because syslog-ng was not developed in Prometheus in mind, and we had to retrofit this. Then we will talk about what other limitations syslog-ng's metrics have, and how we think that log-driven metrics solve those issues. And then we will see some examples and a case study of these metrics in action. So, how many of you have heard about syslog-ng before? Wow, that's quite a lot of hands, more than I expected. Cool. So those of you who don't know, syslog-ng is an old-school log processing service. It is older than Prometheus or even Git itself. A couple of talks earlier about the UX research, Andrei mentioned that Otel came from a tracing background. Prometheus focuses on metrics. Well, syslog-ng is, I think, one of the pioneers of log collection and processing. It was founded in 1998, so it's a pretty old school project. It supports all kinds of protocols for receiving and sending logs. In the last couple of years, we added OTLP support as well, but its main strength was or is cleaning up the syslog mess, the variously malformed syslog messages, which some of you might have seen, which looks like this, and it's not even a mess. This is a correct syslog message. Just for reference, this is the best case scenario, just how logging was always intended to be. So syslog-ng is used in on-prem environments usually, but your Kindle or certain BMW models might be running it too. It has a really small memory footprint, and is written mostly in C. It has metrics, but it exposes them in a custom CSV format. And metrics are not the main data forwarded by syslog-ng. Last year, AxoSyslog forked syslog-ng, called it AxoSyslog. We kept it open source, added a bunch of destinations and a completely new processing language called filter-x, which we'll see some snippets in the slides. And a lot of old syslog-ng maintainers work on AxoSyslog, including its original creator, Balázs Scheidler. Yeah, okay, so what did syslog-ng come up with in regards of metrics? Well, this is the custom CSV format I was talking about. What kind of metrics does syslog-ng expose? We have source and destination side metrics, also a bunch of global performance-related metrics, similar to the metrics we saw in the previous presentation. But they tell about the behavior of syslog-ng itself, nothing about the logs. So we can see that we have queued and written metrics at the HTTP destination, but we don't know what kind of logs were queued or written. We just know some of them. A bit of details about the metrics. So the most interesting parts are that the metric name is at the end. Labels are static. We have like a URL label for the HTTP destination. We have a destination type label, which is HTTP itself. We have the name of the destination configured. It has the information, but it's hard to make sense by a human, I think. Users of syslog-ng usually wrote their own shell scripts to process this info. And then Prometheus came and showed the world how it is done, and we wanted to do it the right way. There were a couple of things that made this the clear choice for us. First of all, syslog-ng's metrics were already cumulative. Why was it like that? Because syslog-ng also stores and processes these metrics, processes the queries, and mostly cumulative information was useful for the user, for like how many messages were sent, how many are there in the queue, and so on. Also for performance considerations, you want to create a counter once, if it's possible, store it somewhere readily available, and update it until the service runs, so you don't eat up a lot of performance by creating metrics regularly. The second point is that syslog-ng's counters were already stateless. It was a really similar architecture that we see in the Prometheus format or style. One line means one counter or one metric. Syslog-ng stores metrics like that. This resonates well with Prometheus' architecture, though we do not support type and help directives because of that, because we do not group these counters together. And also, which was a big plus, that we didn't have to change much for formatting, because CSV formatting and the Prometheus style text formatting is really just string concatenations, so a couple of tweaks did the job. So this is how it looked like in the past, what we can see on the top of the screen, and this is how it looks like now. Though we have backwards compatibility, so you can query the old one too if you still want to use your shell scripts. Okay, cool. So syslog-ng's metrics are now easily processable, but we still have a problem. They only show you how syslog-ng works, but they do not expose anything about the logs themselves, like I mentioned earlier. The logs which syslog-ng is intended to make too easy to handle for the user. So why can't we look into the data with these metrics? At this slide, we can see that sources and destinations have their static baked-in metrics, no meaningful labels regarding the data itself. So why don't we have info there? Well, first, the info you would want to put into the labels are only available later in the pipeline after parsing. In the source driver, those are just characters, and later then the JSON, CSV, or KV parser, or the syslog parser is what is making sense of it. So syslog-ng doesn't have the luxury of having readily available structured data that it can pick the interesting labels from. Secondly, the data is not normalized. So even if we had readily available information in a structured manner, whether the certain field is called dest IP or dst IP is dependent on the data itself. So you cannot know it. You do not know how it will be called when you are compiling syslog-ng itself. And third, even if you had normalized info available, you don't know what is relevant for that certain use case. So needless to say, you don't know all these when you are writing the code for syslog-ng or compiling it, and so on. So we came up with a logical solution to this, I think, which is letting the user define the measurement points themselves. The name of the metrics and the labels can also be customized. So here we can see parse events total metric being generated after parsing, and it is already using the field label. And then after we have filtered the logs, we can count those messages too, call them selected events or whatever you want, and use any labels you would like to. So this is FilterX, the new processing language in AxoSyslog. Actually, it is not available in syslog-ng. And this is how it looks like in it. So first we have a CSV parsing. Then we build up the labels from the parse data. So that's labels equals host and service labels coming from the parsed dictionary. Then we add another label, which is called rec. And we can see that it is accessing data from another place, another object called hostdb. And this is what we call enrichment. So this info was not available in the message itself, the log message itself, but some info was available, and based on that we added new information from outside. Then we measure the parse events total. We put the labels to that function call. We set the increment to 1, but you can set it to the size of the message and call it parsed event bytes total, for example, if you want to measure that. Then you have some filtering. You only continue the processing if the parse level is error. Then you count those messages too. And these are the example metrics that are getting generated from this code. So parse events total, selected events total. We have the host service, rec information, some values for them. And here are some example labels in the wild, which we came up with. We can see that some labels come from the message itself, like the host information, the service the log was generated by, and the transport, or sorry, not the transport, the severity of the log. Some labels are only present in the pipeline, which is very important, I think. I will circle back to that in a bit. So the connector type, like we are collecting Windows events with the VAC connector on that port, is only available in the pipeline. The client IP itself, so the host we are communicating with, is a meta information, and that we are using the HTTP transport is also a meta information, which can be useful for some use cases. And we can see that some labels are coming from enrichment itself. So like we can imagine that we looked up the host, that Azure US East 2 Windows, and we have some values for it, like building location, rec, I guess, or which team it corresponds to, or calculated information like vendor and product, which is yeah, you can imagine anything here, whatever fits your use case. So in summary, I think customizing your metrics in your pipeline gives you observability into your data itself, whatever that means. Okay, so let's see it in action. Not a live demo, but I prepared some graphs we can, or dashboard-like things we can check. So we will do 2 small exercises. You are probably familiar with this if you have done log analytics in Seams before. So let's see what we have here. This is the previously shown classified events total metric visualized with a Sankey diagram. So a small introduction of how we use the Sankey diagram. The full height of the parts show the full sum of this metric. And the height of each label's value show how much the counters with that specific label value contributed to the sum. Yeah, I had to read that because I can't say that by myself. It's complex, but once you wrap your head around it, it becomes like second nature. Also, you can see the intersection with the neighboring labels. So we can see that most of the FortiGate logs had error severity. Some had info, and some we don't know which or what severity it had. Okay, so what infrastructure problem can this Sankey show us? Do anyone have any ideas? Okay, so we see a lot of debug logs coming from a service on a single host, from the app server Nginx host. If this is a production system, I think we do not want to see this many debug logs sent to the SIEM. It pollutes it, it makes large bills and so on. So we can maybe deduce or get a hunch that probably debug logging was enabled after a troubleshooting session. Okay, let's look at another example. Same labels, but a bit different ratios on the Sankey. This is a simple case. We can see that we have a lot of error logs. And the interesting part is the correlation between the host label rack label and the error severity. We can see that most of the errors are coming from rack A. So probably it has some localized problems. And actually, usually these kinds of analytics are done on the logs in Seams. But like I mentioned earlier, you have some metadata available only in your pipelines, so we can have more info here. Okay, so after these warm-up examples, let's see a case study. Let's see how these dynamic metrics helped one of our customers, City's Department of IT and Telecommunications. So this department is responsible for receiving logs from all agents of the city and routing those logs into their respective pub subtopic. Each agency has their own dedicated topic, and there is a mapping between host information and agencies. So we know that this host corresponds to this agency, for example. All the logs are received in a single port, so you can only deduce the info, the host info, from the logs itself. So usually how people solve this is they open like as many ports as many agencies they have, and those agencies can send to only those ports. But here it's on a single port. And it can be possible that the mapping has failed, so we don't know that this one host, so we don't know how, okay, sorry. So we don't know which this host corresponds to, which agency it corresponds to. So the routing logic itself, syslog-ng extracts the host info from the log then it maps that host info to an agency. It sends the log to the correct topic, and if it failed to map, then the logs will be sent to the fallback topic. And the big problem is that the fallback topic must be checked by hand, and the mapping must be updated based on the logs there. So how does the fallback topic look like, or how could it look like? These are fake logs, of course. I highlighted the host information in the logs. So in some cases, it is in the right syslog header place. Sometimes it's under the dev name, key value, pair, or the ID, or underscore age, or sometimes it is not even available. So it's hard to see. It's tedious. You need to manually check the fallback topic. You need to untangle the host info by yourself without the help of the connection meta info you could have had in the pipeline. And you have to worry about not missing a log. So maybe you have tens of thousands or hundreds of thousands log in the fallback topic, and you don't even recognize that you have missed one from a not so chatty client. And you need to do this all day, every day, until no logs end up in the fallback topic. OK, so what solution we came up with? We let the customer use user-configured dynamic metrics in the pipeline. They have added host, IP, agency, and topic labels. And from the Sankey, you can see instantly that there are logs that have no agency or topic, and the host and IP information is available here. So what are the benefits? No more digging in your raw logs. You just look at the Sankey, or even better, you can write some alerts based on those metrics. If you need to document what you have found, you can run some queries and export their output. And as a bonus, now you can warn an agency if it has an unreasonably high load, or you can give them their own view. So what have we learned? First of all, syslog-ng/AxoSyslog supports Prometheus with all the querying, dashboarding, and alerting that it comes with that infrastructure. Secondly, we learned that metrics can be generated from logs, and it makes analyzing the logs easier. We saw this in the case study. We also learned that some really important meta information is only available in your logging pipeline, so it might be too late to do analytics in your SIEM. And even though I'm a syslog-ng developer, I must emphasize that you can do the same with hotel call or any other alternative, I think. And even generating metrics from data in motion is useful, probably even outside of the logging pipeline realm. Thank you for your attention. If you are interested in what we are doing in AxoSyslog, make sure to check it and give a star on GitHub.